Ever wondered what it takes to make the iconic hamburger? Whether it's sizzling on the backyard grill or part of your favorite fast food meal, hamburgers are one of the most beloved foods in America. But behind every perfect bite, there's an incredible journey that begins long before the patty hits the bun. In this video, we're taking you behind the scenes to show you how your favorite burgers are mass-produced in a factory. From raw beef to a sizzling patty, crispy lettuce, and those fluffy golden buns, you'll see just how amazing food processing machines and technology work together to create America's most popular sandwich. Trust me, it's not just about beef, it's a science of its own. Before we dive in, if you're a fan of seeing how your food is made, go ahead and hit that like button, drop a comment, and of course, subscribe so you never miss a bite of the action. The origins of the hamburger. Before we dive into the nitty-gritty of how hamburgers are made in factories, let's take a step back and look at where it all began. You may be surprised to know that the history of the hamburger stretches back to the late 19th century. Though hamburgers are a quintessential American food, their origins can be traced to German immigrants who brought their culinary traditions to the U.S. The term hamburger comes from the German city of Hamburg, known for its seasoned, minced beef patties. But it wasn't until American ingenuity met the mass production needs of the 20th century that hamburgers became what they are today. Popularized in the early 1900s by fast food pioneers like White Castle and later McDonald's, the hamburger quickly became an American icon. Fast food revolutionized how we think about hamburgers, turning them from a homemade delicacy into a product that could be mass-produced for millions to enjoy daily. Today, factories across the U.S. churn out millions of hamburgers a day, using cutting-edge technology to ensure consistency, flavor, and speed. The ingredients: farm to factory. Now, let's break down the core of any good burger, the ingredients. It all starts with the beef, which usually comes from farms across the country. These farms raise cattle specifically for food processing, and the process of transforming this raw beef into a factory-made hamburger begins here. Once the cattle are processed, the beef is transported to food processing factories, where it's inspected for quality by the USDA. Only the highest quality beef makes it through, as these factories are required to meet strict standards to ensure that the final product is safe and delicious. Inside the factory, the beef is cut into manageable portions, and the trimming process begins. This is where excess fat and bone are removed, leaving only the lean meat that will be ground down into the perfect hamburger patty. To give the burgers their signature flavor, seasoning like salt, pepper, and other spices are mixed into the meat using massive food processing machines that can handle thousands of pounds of beef at a time. Grinding and shaping the patties. After the beef is seasoned, the next step is grinding. Large grinding machines transform the seasoned beef into a fine mixture, perfect for forming hamburger patties. Unlike your home kitchen, where you might use a small meat grinder, factory food processing machines are designed to grind hundreds of pounds of meat every minute. These machines ensure that every batch of ground beef is consistent in texture and flavor. Once the meat is finely ground, it's time to form the patties. The ground beef moves down a conveyor belt and into a patty-forming machine. This incredible piece of machinery automatically divides the ground beef into perfectly sized portions and presses them into uniform, circular patties. Each patty weighs exactly the same, typically around 4 to 6 ounces, ensuring that the cooking process will be consistent across the board. It's a well-oiled system, literally. These machines are designed to function efficiently, producing hundreds of burger patties every minute, and because of their speed and precision, the hamburgers you eat from fast food chains or buy at the grocery store will always be the same, every single time. Now that the patties are formed, it's time for what many consider the best part, the cooking. But how do factories cook thousands of burgers so quickly without sacrificing flavor or juiciness? The answer lies in the sophisticated grilling equipment used in food factories. The patties travel through what's called a grill zone, a large conveyor belt with industrial-sized grills underneath. These grills mimic the backyard grilling experience, but on a much larger scale. The patties are seared on high heat to lock in the juices, giving them that delicious, crispy outer layer that burger lovers crave. To ensure even cooking, the patties pass through different process zones. These are stages where the cooking temperature is controlled, ensuring the meat cooks thoroughly while still retaining its moisture. As the patties sizzle away, a steam system may be employed to help keep the burgers juicy. In some factories, a secondary cooking process takes place where the patties are lightly steamed to ensure that every bite is moist and flavorful. Cooling and packaging the patties. Once the patties are fully cooked, they need to cool down quickly to maintain freshness and prevent bacterial growth. In the cooling zone, conveyor belts carry the patties through a temperature-controlled area where they cool rapidly but evenly. It's a crucial step. Too fast, and the burgers dry out. Too slow, and they could spoil. Next comes the packaging process. Using advanced food processing technology, each patty is placed into airtight packaging to preserve its freshness. This ensures that the burger you eventually eat will taste just as good as the moment it came off the grill. Modern packaging machines are a marvel of efficiency, capable of sealing hundreds of patties per minute. And let's not forget labeling. Each package is labeled with the necessary nutritional information, the date it was packaged, and a lot number for tracking. These steps are essential to maintaining food safety standards, ensuring that consumers can trust the product they're purchasing. The buns. From dough to oven. A burger isn't complete without the bun, right? After all, it's what holds everything together. In hamburger factories, bun making is a whole process in itself. It starts with the dough, which is prepared in massive mixing machines capable of handling hundreds of pounds of ingredients at once. The dough is mixed with yeast, flour, sugar, and water to form the perfect burger bun base. Once the dough is mixed, it's portioned into individual bun shapes by, you guessed it, another food processing machine. These dough portions are placed on large baking sheets and sent down the line into enormous ovens that bake thousands of buns in a single batch. Each bun is baked to golden perfection, ensuring it's fluffy on the inside but sturdy enough to hold that juicy patty without falling apart. After baking, the buns go through a quick cooling process similar to the patties before they're packaged and sent off to meet their beefy counterparts. Assembly, putting it all together. Now comes the fun part, putting the entire hamburger together. This step is all about automation. The patties and buns are brought together on an assembly line, where machines carefully place the patties onto the buns. If the burger is being made for a fast food chain, machines will also add toppings like lettuce, tomato, and cheese. Condiments like ketchup and mustard are applied using precision nozzles, ensuring just the right amount of sauce goes on each burger. The finished burgers are then wrapped or boxed, ready for distribution. This highly efficient assembly process allows factories to produce thousands of hamburgers in a short amount of time, all while maintaining consistency and quality. Final packaging and distribution. With the hamburgers assembled and ready, they're packaged for distribution. Large packaging machines place the burgers in boxes or wrappers, which are then sealed to keep them fresh during transport. Factories often use special packaging designed to keep the burgers warm, especially if they're being delivered directly to fast food restaurants. From there, the burgers are loaded onto refrigerated trucks and distributed across the country. Whether they're heading to fast food chains, grocery stores, or even school cafeterias, these burgers are kept at the perfect temperature to ensure they're fresh and ready to enjoy by the time they reach the consumer. So, there you have it. From farm to factory, we've taken a deep dive into how hamburgers are made, revealing the incredible technology and machines that make it possible to produce millions of hamburgers every day. From the grinding of the beef to the perfect baking of the buns, this process is a well-oiled machine, just like the burgers themselves. If you're loving these behind-the-scenes looks at how your favorite foods are made, don't forget to subscribe for more. Drop us a comment about what food you'd like to see next. Innovations in hamburger production. Now, let's talk a little about some of the innovations happening in the world of hamburger production. As more consumers become interested in health and sustainability, factories are evolving to meet those demands. For instance, AI and automation are now being used to improve quality control and reduce food waste in factories. These advanced systems monitor everything from ingredient quality to the exact temperature of the grills. And let's not forget about the rise of plant-based burgers, which are becoming more popular in the market. Factories are adapting their processes to produce alternatives like veggie burgers, using the same high-tech machinery to ensure they taste just as good as the real thing.
The quality of a pizza begins with its ingredients, and large-scale pizza factories prioritize sourcing the best ingredients possible. To meet the enormous demands of production, factories often establish long-term partnerships with farms and suppliers that specialize in producing large quantities of flour, tomatoes, dairy, and toppings. The base of every pizza starts with flour, which is sourced in bulk from suppliers that specialize in high-gluten wheat varieties. High-gluten flour is preferred because it results in dough with great elasticity and chewiness, characteristics that are essential for a good pizza crust. Factories work closely with millers to ensure that the flour meets strict specifications for protein content and moisture. Each batch of flour is carefully inspected to ensure consistency across the board. The simplicity of pizza dough belies the critical role played by yeast and water in the process. The yeast used in factories is often specially formulated for rapid proofing, meaning the dough rises quickly while still developing the flavors associated with traditional dough fermentation. Water quality is another essential factor. Factories carefully filter water to maintain a neutral pH, which ensures the dough consistency and flavor remain consistent across all batches. Tomato sauce production is an art in itself. Factories often source their tomatoes from regions known for high-quality production, such as California or Italy. These tomatoes are harvested at peak ripeness to ensure rich flavor, and they undergo extensive testing for acidity and sweetness before they are transformed into sauce. Cheese, particularly mozzarella, is the crown jewel of most pizzas. Factories source massive quantities of cheese, which are either produced on-site or delivered fresh from dairy suppliers. Mozzarella, with its excellent melting properties, is the most popular choice, but other cheeses, such as cheddar or Parmesan, are sometimes blended in for additional flavor. The variety of toppings available in mass-produced pizzas is staggering. From classic pepperoni to exotic vegetables and gourmet meats, the preparation of toppings in a factory is a feat of logistical precision. Factories source toppings from trusted suppliers who can meet strict food safety standards. Vegetables are flash frozen to preserve their freshness, while meats like pepperoni or sausage are pre-cooked to ensure they are safe for consumption. Before any of these ingredients enter the production line, they undergo rigorous quality control inspections. Samples are taken from each batch, and they are tested for factors like moisture content, flavor profile, and freshness. Only the highest quality ingredients pass this stage and move on to the next step in pizza production. The dough is the foundation of any pizza, and in a factory setting, preparing the dough on a massive scale requires precision and efficiency. Pizza factories produce dough in bulk, often handling hundreds of kilograms of flour at once. The dough-making process begins with mixing the core ingredients: flour, water, yeast, salt, and oil. Industrial dough mixers, which are vastly more powerful than anything found in a typical pizzeria, are used to combine these ingredients. These machines are equipped with sensors that measure the dough's hydration and texture throughout the mixing process. By using precise quantities of ingredients, the mixers ensure that each batch of dough has a consistent texture and elasticity. This precision is crucial for maintaining uniformity in the pizzas that will eventually be made from this dough. After mixing, the dough must be kneaded. Kneading helps to activate the gluten in the flour, which gives the dough its characteristic elasticity and chewiness. In a factory, kneading is done by mechanical arms that simulate the traditional hand kneading process on a much larger scale. These machines stretch and fold the dough repeatedly, working it into a smooth, supple consistency. The goal is to achieve a dough that is stretchy enough to hold up under the weight of toppings, but not so dense that it becomes tough when baked. Resting and proofing. Once kneaded, the dough is left to rest and proof. Proofing allows the yeast to ferment, producing gas bubbles that cause the dough to rise. In a factory setting, dough is proofed in climate-controlled chambers where the temperature and humidity are carefully regulated. These chambers ensure that the dough rises evenly and to the correct height. Depending on the type of pizza being made, the dough may be proofed for as little as 30 minutes or as long as several hours. Factories use specialized technology to monitor the fermentation process, ensuring the dough is neither over nor underproofed. Dough quality checks. Throughout the preparation process, samples of dough are taken for quality checks. Factory workers inspect the dough's texture, elasticity, and rise. Special attention is given to the dough's ability to hold its shape when stretched. If any issues are found, adjustments are made to subsequent batches to maintain consistency across the entire production line. With the dough now fully prepared, it's time to turn it into individual pizza bases. This is where the large-scale machinery of the factory really shines, as dough rolling and shaping are fully automated processes. Rolling the dough. The first step in shaping the dough is to roll it out into large flat sheets. Industrial dough rollers work much like a traditional rolling pin, but on a much larger and faster scale. The dough is fed into the machine, which flattens it to a precise thickness. Factories often produce multiple types of pizza crusts, such as thin crust, regular crust, or deep dish. So the dough rolling machine can be adjusted to create different thicknesses depending on the type of pizza being produced. Cutting and shaping. Once the dough is rolled out, it needs to be cut into individual pizza bases. This is done using automated cutters, which stamp out perfectly round pizza bases from the rolled dough. These cutters can be adjusted to produce different sizes, from small personal pizzas to large family-sized pizzas. Some factories even produce square or rectangular pizza bases for specific product lines. After cutting, any excess dough is collected and reprocessed to ensure that nothing goes to waste. Pre-baking for specific pizza varieties. For some pizza types, such as frozen or pre-made pizzas, the dough is partially baked before the toppings are added. This process, known as par baking, ensures that the crust has a firm structure before it is frozen. Par baking also helps to preserve the dough's texture during freezing and thawing, so that when the pizza is baked by the consumer, the crust has the right balance of crispiness and chewiness. Sauce preparation and application. Tomato sauce is the soul of a pizza, providing the base flavor that complements the cheese and toppings. Factories prepare pizza sauce in bulk, using carefully tested recipes to maintain flavor consistency across millions of pizzas. Sauce production. The sauce used in factory-made pizzas is often a proprietary blend of tomatoes, herbs, and spices. The tomatoes are sourced from large farms and are processed into sauce soon after they are harvested to preserve their flavor and nutritional content. Factories typically have strict controls over the recipe to ensure that the sauce tastes the same across every pizza produced. Like the other ingredients, pizza sauce is subject to quality control checks. Factories use both human taste testers and machines to evaluate the flavor, consistency, and pH of the sauce. These checks ensure that the sauce isn't too watery or too thick, and that the flavor profile remains consistent. Applying the sauce. Once the sauce is prepared, it is applied to the pizza bases using automated machines. These machines are designed to apply an even layer of sauce to each pizza, ensuring that no pizza is under or over-sauced. The sauce is dispensed in a spiral pattern, starting from the center of the pizza and moving outward. This ensures even coverage so that every bite of the pizza contains the right amount of sauce. The machine's speed and volume can be adjusted based on the size of the pizza and the style of sauce application. Large-scale preparation. After the sauce is applied, the pizza moves down the production line to the cheese and topping station. Here, automation plays a crucial role in ensuring every pizza receives the correct amount of cheese and toppings. Mozzarella cheese is the most commonly used cheese for pizza, and in a factory setting, it is processed in bulk. Factories often receive large blocks of mozzarella, which are then shredded or diced on site. The cheese is stored in climate-controlled rooms to ensure that it stays fresh and maintains its optimal melting properties. Once shredded, the cheese is fed into automated topping machines that sprinkle the cheese evenly over the sauce. The machines are calibrated to distribute a specific amount of cheese based on the size and type of pizza. Toppings such as pepperoni, mushrooms, olives, and peppers are also prepared in bulk. Vegetables are washed, sliced, and flash frozen to preserve their freshness, while meats like pepperoni are pre-cooked and sliced into uniform pieces. Each topping is stored in refrigerated units until it is ready to be applied to the pizzas. Automated topping application. Just like the cheese, toppings are applied using automated systems. These machines are programmed to add the correct amount of toppings to each pizza. Sensors monitor the distribution of the toppings to ensure that they are spread evenly across the surface. For pizzas with multiple toppings, the machine applies them in layers, starting with the largest toppings, such as pepperoni, and finishing with smaller toppings like olives or onions. This careful layering ensures that the pizza maintains its structural integrity during baking. The baking process, with the dough rolled out, the sauce applied, and the toppings in place, the pizzas are ready to be baked. In a factory, baking is done in conveyor ovens that are specifically designed for high-volume pizza production. High-speed conveyor ovens. Conveyor ovens are massive machines that can bake hundreds of pizzas at once. The pizzas are placed on a conveyor belt that moves through the oven at a controlled speed. The temperature of the oven is carefully regulated to ensure that the pizzas are cooked evenly. Conveyor ovens have multiple heating zones, allowing the dough and toppings to cook at different rates. For example, the bottom of the pizza is exposed to more heat to create a crispy crust, while the top receives just enough heat to melt the cheese without burning the toppings. Different types of pizzas require different baking times and temperatures. For example, a thin crust pizza will bake at a higher temperature for a shorter time, while a deep dish pizza needs to be baked at a lower temperature for a longer period. Factories have precise settings for each pizza variety, ensuring that every pizza is baked to perfection. Monitoring the baking process. Advanced technology is used to monitor the baking process in real time. Sensors in the oven track the temperature and doneness of each pizza. If the system detects that a pizza is undercooked or overcooked, adjustments are made automatically to the oven settings. This ensures that every pizza that comes out of the oven is perfectly baked. During production, maintaining quality is critical in mass pizza production, and factories employ several quality control measures throughout the entire process. Even with all the automation, human inspectors play a key role in ensuring that the pizzas meet the factory's quality standards. These inspectors visually check pizzas at various stages of production, looking for any imperfections in the dough, sauce application, or topping distribution. Additionally, factories are increasingly using AI-driven technology to monitor production in real time. AI systems can analyze each pizza for consistency, detecting even the smallest deviations from the standard. Food safety is a top priority in pizza production. Factories adhere to strict food safety regulations, including regular cleaning of equipment, temperature checks for ingredients, and rigorous hygiene protocols for workers. The factory environment is carefully controlled to prevent contamination, and all ingredients are stored and handled in compliance with food safety guidelines. Once the pizzas are baked, they are quickly frozen and packaged to ensure that they remain fresh until they reach the consumer. Flash freezing. After baking, pizzas are immediately flash frozen. Flash freezing is a process in which the pizza is rapidly cooled to a very low temperature in a matter of minutes. This prevents the formation of large ice crystals, which can damage the texture of the pizza during storage. Flash freezing also locks in the pizza's flavor and freshness, so that when the consumer bakes the pizza at home, it tastes as though it was freshly made. Once frozen, pizzas are packaged using automated systems. The pizzas are placed in cardboard boxes, which are then wrapped in plastic to seal in freshness. Factories use specialized packaging machines that can process thousands of pizzas per hour. The packaging is designed not only to protect the pizza during shipping, but also to be visually appealing to consumers. Many factories are also moving toward using eco-friendly packaging materials to reduce their environmental impact. After packaging, the pizzas are ready to be shipped to supermarkets, restaurants, and consumers around the world. Pizzas are stored in large, temperature-controlled warehouses until they are ready to be shipped. Cold storage is essential to maintaining the quality of the frozen pizzas. When it comes time for distribution, pizzas are loaded into refrigerated trucks, which keep the pizzas frozen during transit. Large pizza factories partner with logistics companies to ensure that the pizzas are delivered quickly and efficiently. The goal is to minimize the time between when the pizza leaves the factory and when it reaches the store, ensuring that the pizzas remain fresh and safe for consumption. Before retail, before pizzas reach store shelves, they undergo one last round of quality checks to ensure they are ready for consumers. Factories regularly take samples from each batch of pizzas and subject them to taste tests. These tests ensure that the pizzas meet the factory's flavor and texture standards. Additionally, pizzas are tested for structural integrity, ensuring that they hold up during transport and baking. Final inspections. Every packaged pizza is inspected one last time for any defects. If any issues are found, the pizza is removed from the batch and replaced with a new one. The scale and efficiency of pizza production. The process of making pizza in a mega factory is a remarkable combination of food science, engineering, and automation. From sourcing the finest ingredients to baking each pizza in high-speed ovens, every step of the process is meticulously designed to ensure that consumers receive a delicious, high-quality product. As technology continues to evolve, so too will the efficiency and sustainability of factory-made pizza production. For now, factories continue to churn out millions of pizzas, keeping the world satisfied one slice at a time. But have you ever wondered how those noodles packed with flavor are made in such huge quantities? Today, we're taking you behind the scenes into the fascinating world of instant noodle production, where millions of packets are churned out daily to satisfy cravings across the globe. From mixing the dough to sealing the final package, every step is a blend of precision, technology, and innovation. Hit that subscribe button and let's dive into the mesmerizing process of creating the noodles you love. Ready? Let's get started. The journey of instant noodles begins in an enormous warehouse brimming with raw ingredients: wheat flour, water, salt, and a special secret agent known only as kanu. But what makes these elements so special? Let's break it down. Wheat flour is the soul of the noodles, providing structure and elasticity. It is carefully sourced from regions where the climate and soil are ideal for growing high-quality wheat. Factories. Water, of course, is the universal hydrator, but even the water used in noodles is treated with care. Factories employ purification systems to ensure that the water is free from any contaminants, maintaining the pristine quality of the noodles. Salt, the simplest of ingredients, does more than just add flavor. The amount of salt added is carefully controlled to maintain the perfect flavor profile across every batch of noodles. And then there's kanu, the factory's best-kept secret. This ingredient, whether it's an enzyme, a starch, or something else entirely, works. It's the unsung hero of noodle production, and its exact composition is guarded closely by the manufacturers, creating a sense of mystery and allure around the product. Too little mixing, and the dough remains lumpy and uneven. Too much mixing, and the dough becomes overworked, resulting in tough noodles. Achieving the ideal consistency is an art form in itself, and it's only through years of research and development that manufacturers have perfected this process. Too thick, and the noodles become chewy and dense. Too thin, and they'll be too delicate to hold up during cooking. Enter different types of noodles. For instance, ramen noodles are typically thicker than soba noodles, and udon noodles are even thicker still. Once the dough is sheeted to the perfect thickness, it's time for the slicing process. The dough moves along a conveyor belt and reaches a set of razor-sharp blades that slice it into strands. These blades are precisely calibrated to cut the noodles into their iconic wavy shape. The waves aren't just for aesthetics. They help the noodles cook evenly by increasing surface area, allowing water to penetrate more quickly. The slicing process happens in a flash, with hundreds of noodles being cut simultaneously. Each strand is exactly the same thickness and length, a feat of precision engineering that ensures consistency across millions of noodles. This uniformity is important not just for visual appeal, but also for cooking consistency. Imagine cooking noodles where some strands are too thick and others too thin. It would be a disaster. The noodles are now recognizable as the product we all know, but their journey is far from over. After the noodles are sliced, they're sent to the steaming station, a critical step in their transformation from raw dough to a convenient meal. Steaming is a delicate process where the noodles are exposed to just the right amount of. The molded noodles are now ready for one of the most crucial steps in the production process: frying. Instant noodles owe much of their convenience to this step, as frying locks in the noodles' shape and gives them their long shelf life. The noodles are flash fried in hot oil for a few minutes, which rapidly dehydrates them. This dehydration is key to their quick cooking ability. When you add boiling water at home, the noodles rehydrate almost instantly. The oil used in this process also adds flavor and helps preserve the noodles for months without spoiling. The frying process is carefully timed to ensure that the noodles are cooked just enough to maintain their structure, but not so much that they become greasy or lose their flavor. Once fried, the noodles are ready for the next step in their journey. After frying, the noodles are cooled quickly to prevent overcooking. Industrial cooling units use blasts of cold air to bring the temperature of the noodles down in a matter of seconds. The robots work tirelessly to get the noodles from the production line to the shelves in record time, and they do it all with unmatched precision. Instant noodles wouldn't be the global sensation they are without their iconic flavor packets. Whether it's a rich, savory broth or a tangy sauce, the flavor is what turns a simple packet of noodles into a complete meal. At this stage, flavor packets containing seasoning, sauces, and sometimes dried vegetables are added to the noodle containers. Once the flavor packets are added, the noodles and their accompaniments are sealed inside their containers. This process involves placing lids on the cups or packets, which are then passed through specialized sealing machines. These machines use a combination of heat and pressure to create an airtight seal, ensuring that the noodles remain fresh until you're ready to enjoy them. Sealing is an essential step because it protects the noodles from air, moisture, and contaminants. Without a proper seal, the noodles could become stale or lose their flavor over time. Factories use state-of-the-art technology to ensure that each package is sealed perfectly, creating an airtight environment that preserves both taste and texture for months. In addition to preserving, while others employ robotic sensors that can detect even the slightest imperfections. In some cases, samples from each batch are cooked and taste tested to make sure the flavor is just right. Quality control is a vital step in the colorful designs that draw customers in. From the bold fonts to the vibrant images of steaming bowls of noodles, the packaging is carefully crafted to trigger a craving before you even open the packet. In fact, There's a science behind the design of noodle packaging. Companies often conduct consumer research to identify which colors and images are most appealing. Red and yellow, for example, are common on noodle packaging because they are known to stimulate appetite. The goal is to make the product irresistible, even countries and even continents, all while maintaining optimal storage conditions. The noodles are carefully monitored to ensure they remain fresh and safe to eat throughout the journey. From the moment the noodles leave the factory to the moment they arrive on store shelves, every step is meticulously coordinated. This seamless distribution system is one of the reasons why instant noodles are available in so many countries, and why they can be delivered so quickly after production. These tests are the final line of defense, ensuring that every bite is as delicious as the last. For noodle brands, reputation is everything, and these final checks help maintain their standing as a reliable and beloved food option worldwide. Bananas. We all love them, but have you ever wondered how they go from the farm to your fruit basket? Stick around, because we're about to peel back the secrets of large-scale banana farming in the United States. It's a lot of fun, and you won't believe the process behind this top-selling fruit. Let's get growing. Before we get started, be sure to press that subscribe button and touch the bell so you never miss our deep dives into the fascinating world of food production. Trust me, you'll want to stay around for this. Banana cultivation begins long before the first banana grows. It all starts with choosing the ideal planting material. Bananas, unlike many other crops, do not grow from seed. Instead, producers employ immature banana plants known as suckers or shoots, which grow from the mother plant's root. These suckers are critical to banana proliferation and must be carefully chosen for their vigor, health, and disease resistance. Before transplanting these plants into the field, farmers thoroughly inspect them for symptoms of disease such as banana wilt, fusarium, or worms. Ensuring that only the healthiest and strongest plants are selected is critical to creating a profitable and plentiful crop, as a single sick sucker can threaten a whole row of plants. Bananas grow in warm, tropical regions with well-drained soil. Thus, Hawaii and southern Florida are suitable locations for banana production. After selecting the appropriate planting material, the preparation of the land begins. Before planting can begin, the soil must be fully prepped, which is no easy task, particularly on large-scale banana plantations spanning hundreds or even thousands of acres. In large-scale operations, land preparation entails plowing the fields to loosen the soil and promote drainage and aeration. Farmers can replenish the soil with organic materials such as compost or manure, ensuring that it has the nutrients required for banana development. This step is critical because bananas are heavy eaters and need a nutrient-rich environment to grow. In areas with unpredictable rainfall, irrigation systems are implemented during the land preparation stage. Irrigation systems assist to keep soil moisture levels constant, which is critical for banana plant health. On bigger farms, modern irrigation techniques such as drip or sprinkler systems are utilized to guarantee that water reaches the plant roots while preventing soil erosion or water waste. Soil conditioning, such as adding lime to regulate pH levels, may also be used to guarantee that bananas grow in the best conditions. Once the soil has been prepared, it is time to plant the suckers. Planting on a big scale requires a combination of mechanical techniques and manual effort to ensure that suckers are planted at the proper depth and spacing to optimize growth potential. The depth at which the suckers are planted is crucial for ensuring that the roots have efficient access to water and nutrients. Suckers are often planted 6 to 8 feet apart to provide the plants enough room to grow without competing for sunshine, water, or nutrients. Spacing is also important for ensuring that each banana plant has adequate area to build a strong root system, which will support the big bunches of bananas that will eventually mature. Proper row spacing of 10 to 12 feet between plants allows for easy mobility of people and machines, which is necessary for weed control, fertilizer, and harvesting. With hundreds of banana plants on each acre of land, it's critical to maximize space while ensuring each plant has the best growth circumstances possible. Water is a vital component in banana growing. Bananas are tropical plants that require regular moisture to thrive, and managing water resources correctly is one of the most difficult parts of large-scale banana production. Too much water can cause root rot, while little water can inhibit development or provide low harvests. To overcome this, big banana farms utilize complex irrigation systems, such as drip and sprinkler systems, to guarantee that the plants receive the proper quantity of water. Drip irrigation is particularly popular since it provides water straight to the roots, reducing evaporation and conserving water. This approach is also used to avoid excessive watering, which can cause soil erosion and nutrient loss. In dry places, farmers may collect rainfall or use reservoirs to guarantee that water supplies are consistent throughout the growing season. Water management is especially crucial throughout the blooming and fruit development stages, since inadequate water might result in smaller or lower quality bananas. Bananas are considered to be heavy feeders, which means they require a lot of nutrients, especially potassium, to develop effectively. Banana plants cannot produce large, healthy bunches of fruit unless their nutritional levels are balanced. Fertilizer is frequently applied on big farms using a process known as fertigation, which involves mixing nutrients with irrigation water and delivering them directly to the plant roots. This mechanism guarantees that plants have a consistent supply of nutrients throughout their development cycle. Farmers utilize a combination of organic and chemical fertilizers to provide a balanced nutritional profile that promotes healthy plant development while remaining ecologically friendly. Organic fertilizers, such as compost, promote long-term soil fertility, whereas chemical fertilizers provide a fast boost of critical minerals like nitrogen, phosphorus, and potassium. The careful control of nutrients guarantees that banana trees can produce fruit throughout numerous seasons. Weed control is a crucial challenge on banana plantations, as weeds compete with banana plants for sunshine, nutrients, and water. Weed management on big banana plantations is frequently done using a mix of mulching and selective herbicide application. Organic mulches, such as dried banana leaves or straw, are often used to control weed development while retaining moisture around the plant's base. This strategy not only prevents weeds from taking over, but it also helps to control soil temperature and moisture. In certain circumstances, herbicides are employed to control invasive plant species without harming banana plants. However, effort is taken to limit environmental effect and avoid disrupting surrounding ecosystems. On organic banana plantations, mechanical weeding or natural measures such as cover crops may be utilized to control weed development. Banana plants grow quickly and need to be pruned on a regular basis to provide good fruit. Pruning entails removing dead or dying leaves that may house pests or illnesses, as well as thinning out extra suckers. Banana trees normally generate numerous suckers, but too many can cause overcrowding and diminished fruit size. Farmers can concentrate the plant's energy into fruit production rather than needless development by eliminating extra suckers. Regular trimming also improves airflow around the plants, which reduces the danger of fungal illness. On big farms, professional personnel or machinery are utilized to effectively prune plants, ensuring that each one is adequately maintained. This role is especially vital during the blooming and fruit development periods, when the plant must concentrate its energy on generating bananas. Banana plants are susceptible to a wide range of pests and diseases, including nematodes, banana weevils, and the deadly Panama disease. To control these problems, large banana plantations rely heavily on integrated pest management, IPM strategies. IPM uses a combination of biological, chemical, and cultural management strategies to keep pest populations under control while reducing the usage of hazardous pesticides. Natural predators, such as parasitic wasps, are utilized to control insect pests, while crop rotation and soil management practices help to lessen disease burden. Regular monitoring and inspections are critical components of pest and disease management. Farmers and staff routinely inspect the plants for symptoms of infestation or sickness, allowing them to handle issues before they spread. Banana plantations may secure their crops while reducing environmental impact by maintaining a healthy ecosystem and employing sustainable pest management practices. After 9 to 12 months of development, banana plants begin to bloom. An inflorescence is a single enormous bloom that emerges at the top of the plant. This flower will eventually grow into a bunch of bananas, often known as a hand. The blooming stage is crucial for banana production since the plant's health directly influences the quality and quantity of the bananas. Farmers devote special attention to the blossoming stage, making extra efforts to ensure that the plants receive the nutrients and water they require. During this period, workers may apply more fertilizer or change irrigation schedules to meet the plant's energy requirements. Any damage to the blossom might result in lesser harvests. Thus, farmers take great steps to safeguard the growing fruit. As the bananas grow, producers take further precautions to safeguard them from pests, illnesses, and environmental variables. A typical technique is to wrap budding banana bunches in protective plastic bags. These bags protect the bananas from pests like fruit flies, as well as harm from sunlight or freezing weather. To avoid infestations, the bags may be sprayed with pesticides. Bagging also ensures that the bananas develop uniformly and without flaws, which is critical for producing high-quality fruit for export. This procedure is especially crucial for large-scale farms that export their bananas to overseas markets, where customers seek blemish-free, consistent fruit. Banana harvesting is a labor-intensive procedure that demands both expertise and time. Bananas must be collected before they reach full ripeness to avoid spoilage during transportation over large distances. This is where the art of banana cultivation comes into play. Harvesters must be able to determine the optimal moment to gather the fruit. Bananas harvested too early may not mature correctly, while those picked too late may deteriorate during shipment. On vast banana fields, workers use sharp knives or machetes to chop down enormous bunches of bananas weighing up to 80 pounds. The gathered bunches are carefully handled or loaded onto trucks or conveyor systems and transported to the packaging factory. This procedure is performed with care to prevent harming the fruit, as any bruising might diminish its market value. Harvesting teams on big farms frequently operate year-round, since bananas do not have a specific season and may be gathered constantly after the plants mature. After harvesting, the bananas are transported to a processing plant where they are meticulously sorted, cleaned, and packaged. Workers now check the bananas for size, quality, and maturity. Any bananas that do not fulfill the high-quality criteria for export are sorted and sold locally or processed into banana-based items like banana chips, puree, or baby food. Bananas that pass inspection are washed to remove dirt, sap, and any bugs that may have remained on the fruit after harvesting. Once cleaned, they are placed in specially constructed crates to safeguard the fruit throughout shipping. These boxes are frequently lined with padding or cushioning to avoid bruising or injury. The packaged bananas are then ready for shipment, either by truck, train, or sea freight, depending on their final destination. Massive-scale banana farms have highly structured and efficient sorting and packaging processes, with automated methods being employed to manage the massive amounts of fruit being processed. Quality control is critical, since bananas are one of the most exported fruits in the world, and maintaining a high standard is essential for success in the competitive worldwide market. After being processed, packed, and placed onto refrigerated trucks or shipping containers, the bananas are transported to markets throughout the United States and around the world. Transportation is crucial to ensure that the bananas arrive fresh and in good shape. Because bananas are often collected before they are fully ripe, the refrigeration procedure, known as cold chain logistics, slows the ripening process and prevents the fruit from spoiling before it reaches its final destination. Bananas transported abroad are shipped in containers with temperature controls that keep the fruit at an appropriate temperature, often about 58 degrees Fahrenheit, 14 degrees Celsius. This keeps the bananas fresh while in transportation and allows them to mature naturally once at their destination. Whether delivered by truck, train, or sea, logistics are critical in the banana sector, with intricate procedures in place to guarantee that bananas reach customers at the optimal maturity stage. After reaching their destination, the bananas begin a vital stage known as post-harvest management. Bananas are ripened in specialist chambers before being sold in supermarket shops. These ripening chambers combine temperature, humidity, and ethylene gas, a natural plant hormone, to cause the bananas to ripen uniformly. The conditions in these facilities are continuously monitored to ensure that the bananas reach the appropriate ripeness before being sent to retailers. The timing of the ripening process is critical to ensure that bananas are ready for sale when they arrive at grocery store shelves. Too much ripening, and the bananas may rot before they are sold. If the bananas do not mature sufficiently, they may be excessively green and unpleasant to customers. Once the bananas are completely ripe, they are sent to retailers and displayed for customers to buy and enjoy. This is how large-scale banana cultivation works on American farms. Every stage of the process, from careful planting material selection to thorough post-harvest management, is intended to guarantee that you receive the finest bananas available. It's fascinating to consider the trip a banana takes before reaching your local grocery store. From a little crop in the field to being carried hundreds of kilometers and ultimately arriving ready to eat. Next time you eat a banana, take a moment to appreciate the hard work, knowledge, and technology that allows this delightful fruit to be available all year. If you love this deep dive into banana farming, make sure to subscribe and stay tuned for more behind-the-scenes views at how your favorite foods are cultivated and produced.